There are many real-world applications to these radical expressions. For instance, this is a formula that the police often use to help them determine the speed at which a car was driving based upon the condition of the road and the distance of the skid. This is a formula they can use to estimate that speed that the driver was driving. And so there are times when we want to take into consideration a formula like this and use it instead to find speed. If we knew the speed, we could use it instead if we knew the speed to find maybe what the length of the skid would be if the car were traveling at that speed under particular conditions. So, in other words, figuring out how much distance does a car need to leave between itself and the car in front of it in order to be able to ensure that that car will be able to stop. In this formula, S represents speed in miles per hour, D is the length of the skid marks in feet, and then F is a coefficient of friction. Basically, that's where you factor in the condition of the road. Was the road concrete? Was the road asphalt? Was the road wet? Was the road dry? Was the road snow covered? Was the road ice covered? And so on. That's the degree or coefficient of friction. So let's say we want to take this formula and use it to determine how fast a car was traveling. If the coefficient of friction is 0.35 and the skid mark was a length of 325 feet. Well, that's pretty simple in that all we have to do is enter the length of the skid mark, which is 325 feet for D, and then the coefficient of friction based upon the conditions under which the car is driving, which was given to us to be 0.35. Now, one must be careful when they're doing this in their calculator because you want to make sure you take the square root not just of the number 30, but of the product of those three numbers under the radical. So when you do the square root, you're going to want to be sure that you put parentheses around those three numbers that you're finding the product of. So the square root of the answer to 30 times 325 times 35 is about equal to 58 miles per hour. So we could estimate that that's how far that car was driving. Now, in addition to this, we could say, all right, how might we rearrange this formula to determine the amount of distance that needs to remain between a car and the car in front of it under certain conditions in order to ensure that the car will be able to stop in time without hitting the car in front if it stops. So say we want to solve for that, therefore, we want to solve for D. Well, D is underneath the radical, and the radical acts as a grouping symbol, so we have to eliminate things outside of the parentheses or grouping symbol first. The way we undo a square root is by using its opposite operation. The opposite of square rooting something is squaring that something. So I'm going to square both sides of my equal sign. And in turn, I'll have S squared is equal to just the stuff under the radical, which is called by the radicand. So now I have S squared is equal to 30df. Keep in mind, I'm trying to get D alone. Well, it's being multiplied by 30f. Therefore, the way we undo multiplication is by using its opposite operation, which is division. So we're going to divide by 30f on both sides, of course, of our equal sign. That will allow us to eliminate the 30s and the f's, and we have a new form of this equation, and that is that D can be found by taking the speed at which the car is traveling, square it, and divide it by the product of 30 and the coefficient of friction. So if a car was traveling, for instance, at 70 miles per hour on the highway, under conditions that produced a coefficient of friction such as 0.35, we could substitute 60 in for S, 0.35 in for F, and find the approximate distance that needs to remain between that car and the car in front of it.